Today I'm going to take you through a time of flight calculation question. If you remember from our work in September, these often caused us quite a lot of difficulty, so I think it's worth reviewing how to do these questions at this point in the course. So the question we're going to focus on today is asking us to consider a carbon ion, okay, with a positive charge, and that takes 1.23 times 10 to the minus 5 seconds to travel along the flight tube in a time of flight mass spectrometer, having been given 5.94 times 10 to the minus 17 joules of kinetic energy. And the question is asking us to calculate the length of the flight tube. Okay, now if you remember, with these questions, there's a couple of sort of variables that we need to take in consideration. So before we approach this question, I'm just going to remind you of those. So we've got time, we've got distance, we've got kinetic energy, and mass. And it's really important with these questions that we're always working in the correct units. So just pause the video and see if you can remember the correct units for each of these variables. Okay, so you should have remembered, therefore, that time is in seconds, distance is in meters, kinetic energy is in joules, and mass is in kilograms. So when you're working through these questions, it's always worth making sure that you're working in the correct number of units. Now, I'm going to go through this in the way that I would approach this question. However, you may have your own preferred style, which we can, of course, look at in some future examples as well. So I've previously introduced you and derived the following equation, that the time of flight of an ion is equal to the distance times the square root of the mass divided by 2 times the kinetic energy. And of course, you might just want to note here that this is equal to the square root of the mass divided by the square root of the kinetic energy. Okay, that's what that term means there. So I'm just going to add in the units. We've got meters, we've got seconds, meters, kilograms, and joules. So happy here that the time has been given in seconds, the kinetic energy has been given in joules. We haven't been given the mass, but we do need to be able to work that out ourselves. And obviously, we need to figure out what the distance of the flight tube is. So let's take the 12 and 6 carbon ions. Okay, so if you remember that this mass number here, okay, means that 1 mole of these ions is equal to 12 grams. 1 mole contains 6.022 times 10 to the 23 particles. However, in this question, we need to be working out the time of flight of a single ion. So we need to work out the mass of a single ion. Okay, so pause the video now and see if you can work out how you would do that. Alright, so to work out the mass of a single ion, we can say that if 1 mole, or 6.022 times 10 to the 23 particles, is equal to 12 grams, then 1 ion, or 1 single particle, must be equal to 12 divided by 6.022 times 10 to the 23. And if we put that in our calculator, we get 1.99. Let's have a look here. 12 divided by 6.022 times 10 to 1193. I'm going to keep working at 4 significant figures here, times 10 to the minus 23. Now that is in grams, okay, but we need to be working in kilograms. So in kilograms, that's equal to 1.993 times 10 to the minus 23 divided by 1,000, which is 1.993 times 10 to the power of minus 26 kilograms. So now we've got our term for mass, we've got our term for time, and we've got our term for kinetic energy. So what we need to now do, okay, is to rearrange this equation here. So if time is equal to distance times square root of the mass divided by the square root of 2 times the kinetic energy, we can rearrange this. Okay, and the first thing I'm going to do is bring 2 times kinetic energy up to top here. So we're going to have T times the square root of 2ke. And then if the mass is timesing up here, I'm going to bring it across this side and divide it. So divided by the square root of the mass, which is going to give us equal to D. Okay, so perhaps if you're unsure about that, just pause the video and see how we got to this point here. And then we simply input our numbers. So D is equal to, so we were given time in the question, which was 1.23 times 10 to the power of minus 5 seconds, times, and here comes our square root 2ke, 2 times 5.94 times 10 to the minus 17, again given to us in the question, divided by the square root of the mass that we just worked out, which is 1.993 times 10 to the power of minus 26. And if we put that into the calculator, our answer comes up with 0.95 meters. Okay, now we would expect that, okay, or we could be happy with that answer because distances, okay, are typically in the range of 0.5 to say 2 meters. If you came out with a flight tube that was about 2 kilometers long, you might have identified that you'd gone wrong somewhere. So I hope you found that useful. Perhaps have another play through this, make some of your own notes, and then have a go at some of the examples found on the ChemSheets resource that I've given to you.